So children, today we will discuss in brief about covalent bonding. Covalent bonding. These children, all of you should listen carefully. Covalent bonding. Already we have discussed in brief about ionic bond. I hope everyone remembers. Ionic bonding means complete transfer of electrons was ionic bonding. But covalent bonding means sharing of electrons. Sharing of electrons is called covalent bonding. Sharing of electrons. Okay, so ionic bond and covalent bonds, what is the difference? Differences we'll discuss after discussing covalent bonds. In covalent bond, they share electrons. How do they share electrons? Before sharing of the electrons only, again I want to discuss hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, okay, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, calcium. Okay. Till here let me discuss. These are the elements we have, some of them. Okay, this is 0, this is 0, and argon is also 0. Remaining all elements also will try to attain their stability. I told millions of the times. Okay, so in this process they may give, they may take, or they may share. The sharing of the electrons is called covalent. When will they share? Means when they can't give or take, then they will share. When they can't give or they can't take, then they will share. So in which position like that it is possible, sir? You will ask. No, please listen, children. I was saying so many examples, almost 10, 15 examples I've covered. Then I hope you will be understanding. Okay, first one. Let's discuss hydrogen. Pure hydrogen atom is unstable. But once they form molecule, they become stable. How? Children, hydrogen atom number is 1. It means hydrogen is 1. Another hydrogen is there. It is also having 1. If this gives to this will not get stability, this will get stability, helium stability. If this gives this will not get stability, this will get helium stability. No one can give, no one can take. In this position, they share. How they share? This hydrogen will say from today onwards, we both are best friends. Over. Now this hydrogen is having 2 electrons, so helium stability. Then this hydrogen will say, okay, let's be very good friends. So what? This also got helium stability. Like that, they are sharing one pair of electrons between them. And that's why we write always hydrogen is H2, and H2 is undergoing what type of bond? Single bond. Why we write H2? Because when individual hydrogen atoms are unstable, but once they form molecule H2, they will become stable. They will become stable. Now, sir, we need to understand if you say one more example. Okay, one more example. Nitrogen. What is the atomic number of nitrogen, children? Atomic number of nitrogen is 7. Okay, 7 is nearer to which table element? Neon. To go to neon, it requires how many electrons? 3 electrons. Nitrogen want 3 electrons. It wants 3. Okay, 2 comma 5 no children. Outermost shell 5 are there. Okay, okay. Outermost shell 5 are there. Okay, no need to write the text. How many it want? That much only. If you write is enough, children. It wants 3 electrons. Under nitrogen is there. It is also want 3 electrons. In this case, if this gives, this will get stability, this won't. If this gives, this will get stability, this won't. So in this case, both will share. Okay, this nitrogen will share these 3 electrons. Now, how much children? See, 7 electrons are there, no? 1, 2, 3, 4, 5, 6, 7. Okay, 8, 9, 10. Now, this nitrogen got last. This nitrogen also, how many 7 electrons? 1, 2, 3, 4, 5, 6, 7. This also will share like this electrons. Now this nitrogen also got initially 7 are there, 7 plus 3, 10. Now only on configuration. So nitrogen will have 3 shared pair of electrons between them. And nitrogen will form what bond? Triple bond. But we will write N2 only, but it will have triple bond. Out of every 3 bonds, one first bond is called sigma bond. Remaining 2 are called pi bonds. Remaining 2 bonds are called pi bonds. First, if 5 bonds are there, first one is sigma, remaining 4 are 5. Pi bonds. First one is sigma, second, 2, and third are called pi, pi bonds. Okay, children? I hope you are able to understand now. Little bit you understand. Okay, no problem. So many examples. You'll understand. Okay. Oxygen. Okay, children. Oxygen. Oxygen atomic number is how much? 8. Okay. 8 means 2 comma 6. It is in need of how many electrons? Oxygen to go to neon? 2 electrons. It wants 2 electrons. Another oxygen is there. It also wants 2 electrons. No one can give, no one can take. So it will say from today onwards we both are best friends. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stability. This also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This also sharing stability. Now this and forming bonds and what oxygen molecule. This will get stability now and this will become happy and it lives happily forever. Okay, children. Individual oxygen atom is unstable, but once they form oxygen molecule, it is very, very stable. Okay, children. I hope you are able to understand little. Not much, but little you are able to understand. I know that. Okay, some more examples. We show fluorine. Atomic number of our children 9. It is in need of how many electrons? Just one. Okay. Fluorine require one electron. Under fluorine also require one electron. No one can give, no one can take. 9 plus 1 10. 9 plus 1 10. Both are happy. F2 molecule. Molecule is stable. Atom is unstable. Fluorine. One more example, sir, please, sir. Oh, sure. Chlorine. Chlorine atomic number 17. 17, if it wants one electron. If it gets one electron, it will get argon stability. It will get argon stability. These both will share argon stability. This both will share argon stability. So chlorine will form single bond and Cl2. That's why we'll write Cl2. Never will write Cl. Chlorine means no one will write Cl. Cl means atom. Cl2 means molecule. Okay, you know, like this. Then you will get one out. Sir, you are telling everything covalent bond. Okay, it's good, fine. Everywhere you are taking same atoms, and doing it means other atoms won't form. Means yes, they will form. Covalent bond is of two types, polar and non-polar. Whatever I said, they all are polar. No, sorry, no, non-polar, actually, non-polar. Okay, now coming to polar. Polar means different atoms will involve. Different atoms will involve. The basic example I will show. I will show the basic example. Children, different atoms will involve. The first and foremost example I will show children water. I hope everyone understood all these sums, children. Okay. Don't copy children when I'm saying. Later you can open the video and you can see the video and you can copy them easily. Okay. Listen carefully when I'm saying the class. Listen. Now, children, slowly listen. First famous example: water. Water. How water is formed. Oxygen. Oxygen, how much children? 2, 6. No, it is in need of 2 electrons to go to. It is in need of 2 electrons to go to neon. Hydrogen. Hydrogen is in need of 1 electron to go to helium. And the hydrogen is also, it is in need of 1 electron to go to helium.
Helium stability.
This hydrogen will share like this and got helium stability. Fantastic. This got stability. This hydrogen also will say, I will share like this. This also got stability. This oxygen will keep quiet. You are thinking, no, it won't keep quiet. It will share. Cello will share all like this. And they will be a happy family and they form H2O molecule and they will live happily forever and ever. Covalent bond, sharing. No one is giving, no one is taking children, they will sharing. Sir, really we didn't understand anything if you say like that. One more example. Ammonia, NH3. Ammonia. Don't think I'm taking all easy examples and I'm explaining. So whichever are easy for you to understand, I'm explaining. That's all. Ammonia. Nitrogen is in need of 3 electrons, 7 to 10. If you go to 7 to 10, no children, 3 electrons. Hydrogen requires 1 electron. Hydrogen requires 1 electron. Hydrogen requires 1 electron. Hydrogen got helium stability. Hydrogen got helium stability. Hydrogen got helium stability by sharing 2 electrons. Nitrogen initially has 7 electrons. It wants 3 more. So it will take 3 electrons of hydrogen and it got stability. This is how ammonia forms. No, sir, we won't accept. Yesterday we were doing methane. No, children, let's take methane now. I was explaining helium. I was shouting, but no one understood. Today I will explain. Carbon is in need of 4 electrons. Because 6 to 10, no, children, carbon is in need of 4 electrons. Hydrogen is in need of 1 electron. 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 Hydrogen get what stability? Helium stability. Hydrogen get what stability? Helium stability. Hydrogen gets what stability? Helium stability. Hydrogen get what stability? Helium. Hydrogen so happy. But what about carbon? Carbon it has its 4 electrons. 4 means 6 actually. 2 comma 4, 6 electrons. 6 plus it wants 4 more. It will take all. The instability like this. This is methane. Yesterday we discussed covalent bonds. No, sir. One more example. Take hydrochloric acid. Location. Hydrogen is in need of 1 electron. You all know. Chlorine also in need of 1 electron to go to argon. Hydrogen will say we are best friends. Chlorine will say yes, we are very best friends. So HCl molecule. This is a covalent bond. This type of bondings between two dissimilar atoms are called polar covalent bonds. Why polar covalent bonds? Same atoms means non-polar, different atoms means polar. Why different atoms means polar means one time I will say if you understood good. If you didn't understand, leave it children, it's not important for you. Why they are saying polar covalent bonds means oxygen is more electronegative than hydrogen. Even though they both are sharing these electrons, all of them together, oxygen being more electronegative, what it will do, it will little bit it will drag these two electrons towards it. It will say, I will keep it with me, don't worry, I will keep it with me, don't worry. Who will say oxygen? So these electrons, little they go towards this, little minus charge, little plus charge. Actually, covalent bonds do not have charges, but little minus charge, little plus charge you will get. Such type of getting little minus and little plus charge is called polar covalent bonds. Everywhere same. Here nitrogen will take, here carbon will take, here chlorine will take, like that. They will take, children. Okay? Why they will take? Because little, because being more electronegative. What is electronegativity in periodic classification? I told tendency of atom to take their electron. Okay, children, this is HCl. No, sir, we didn't understand. We want some more examples. Children, we'll do carbon dioxide. Famous question in board exam. So many times they ask us. How many times they ask? I only know that many times they ask. Carbon dioxide. Carbon require how many electrons? 4 electrons. Yes, sir, no. 2 comma 4, no, right? 4 electrons. Oxygen require how many electrons? 2 electrons. Oxygen require 2. Oxygen require 2. Oxygen 2 share happy. Oxygen 2 share happy. Carbon 4 share happy. This is carbon dioxide structure. In spite of saying million times, many children will write instead of 4, 2 electrons they will write and they'll come out and they'll say, you sir, we found out. We can't do anything after writing exam. This is carbon dioxide. Okay, children. Those who did not understand, one more example. Future sulfur is there. Sulfur. Okay, sulfur is in need of 2 electrons. Sulfur is in need of 2 electrons. Okay, sulfur is 16 much. Okay, sulfur dioxide is no sulfur dioxide. Okay, okay, sulfur dioxide will become tough for you. I will say later. Now one more example. Hydrofluoric acid. Hydrogen is in need of 1 electron. Fluorine is in need of 1 electron. This will get helium stability. This will get neon stability. Hydrofluoric acid HF. Okay, children. Any other example? H2S, hydrogen sulfide. Sulfur is in need of 2 electrons, children. Sulfur, because 16, no? 16 to 18 need to go. 16 to 18 it is in need of 2 electrons. Hydrogen is in need of 1 electron. Hydrogen is in need of 1 electron. Helium stability. Helium stability. Ionic stability. Sulfur will get ionic stability. Okay, children. You're able to understand. Yesterday till decane you did all this only, children. Stability is only. Yesterday till decane, methane to decane I made you do. Why? This only. Stability is only we made you. This swatch. Any of your favorite molecule is there? You want me to explain? Which you like? Any favorite molecule is there for anyone? If you want, I will tell.
CH3COOH.
Okay. CH3COH she wanted. Seems okay. Powerful, isn't she? Children, thank God she didn't have C6H6. My goodness. CH3COOH. Children, CH3COH. Please see, children. Carbon. Carbon. Okay. Carbon. Carbon. Carbon is in there. Please see, children here. First I will explain. Hydrogen will get helium stability. Hydrogen will get helium stability. Hydrogen will get helium stability. Oxygen will get neon stability. Okay, children, here oxygen will be like this. Okay, carbon will get what stability? Neon stability. Carbon will get what stability? Neon stability. Okay, children, COOH. Okay, children, hydrogen will get what stability? Helium stability. Oxygen will get what stability? Neon stability. Like CH3COH. CH3COH. CH3COOH. Like this. Actually, I will make you do all these things, children. Don't worry, carboxylic acids. I will do methanoic acid, ethanoic acid, propanoic acid, butanoic acid, up to decanoic acid. I'll make you do all these things. If you ask or not, I will make you because this question regularly they are asking in boards. CH3COH, CH3COOH. Children, actually, 4 electrons. 4 electrons because oxygen will form double bond. I'll explain, children. Don't worry. CS3COH, I'll explain. Any other molecule, your favorite molecule is there, then you can ask me, children.
H2SO4.
H2SO4. Oh, okay, last one, children. Okay, H2SO4. Sulfuric acid. Fast children, H2SO4. Children, sulfur is in need of 2 electrons to go to iron. Okay. Mm, hydrogen is in need of 1 electron, children. Oxygen is in need of 2 electrons. C, children. 1, 2, 3, 4. Oh, children. That's all. See, hydrogen got helium stability. Sulfur got neon stability, children. Here also this electron will be there. So this electron also. Okay. Each oxygen, children. Each oxygen will get like this stability. Each oxygen will get like this stability. Each oxygen will get like this stability. Each oxygen will get, and hydrogen got helium stability again. This is H2SO4. H2S. H2S 1, 2, 3, 4. If you want